Let's change the automotive world forever, creating something that has never existed before. Taking on new challenges in eMobility for a brighter future and a cleaner planet. We can work together to innovate practical solutions, to meet ambitious targets of today and set the trends of tomorrow. We support you, deliver highly efficient battery components and charging infrastructure designed for long-lasting performance, from flame-retardant plastics in durable orange to thermal management and solutions to reduce noise, vibration, and harshness, safety and durability that make a difference. Materialize your eMobility ambitions. Freedom to design with high-performance plastics and technical expertise to launch market-ready products, from concept testing to serial development with BASF. Your automotive concepts become reality, built to meet specifications and expectations. Together, we can inspire innovation and deliver on the promise of eMobility worldwide.
BASF. We create chemistry.
Thank you very much for the introduction. So I would like to start with giving you a short overview, especially about the powertrain landscape. So this is the first agenda point for today. After this, we talk also about different kind of charging systems, and especially about which individual component is needed for the different charging systems. And finally, we are going to answer the question if charging really ends at the car, or if there are also some components related, which are in the car, which are also very important in terms of charging infrastructure. So starting with the first point, I mean, if we talk about powertrain development in general, we see here some big changes in the next few years. The changes has already started. If we look on the left side, in the last year, we saw 2 years ago, we would say the major parts coming from internal combustion engine. It's what you see highlighted here. The smaller part, also the European, the blue highlighted mark is coming from the battery electric vehicle. Here we see, I would say, two changes. The major change is that the share of battery electric vehicle is increasing. So this is I would say what happened in future in general, but also plug-in hybrid electric vehicles and also full hybrid electric vehicle will increase, and therefore I would say the E&E components in the car definitely increase. And for both options here, for the plug-in hybrid electric vehicle and the battery electric vehicle, we need some kind of charging system to charge the batteries in the car. Therefore, I would say more or less three technologies are common. One of these technologies is called the mobile charging system. This is what you typically have in your car. It's a mobile device. You could take it wherever you want to drive. You just need a plug to charge it, and for sure a power supply, and then you could charge your car. In the center of the slide, we see a Wallbox. This is, I would say, what we typically see on the private charging system or residential charging system. So you could install it in front of your house or in front of your garage, and use it to charge your private car. And on the right side of the slide, you see the public charging station. This is something what typically is in front of a supermarket or in any public charging area. So if we look a little bit deeper in the differences of these three charging technologies, we see here the power supply of the mobile charging system is normally AC, and also the Wallbox is normally covered with AC. Public charging stations are depending on their energy level covered with AC or DC. So this is something which affects the charging time. The charging time of a mobile charging system is, I would say, has the highest charging time. So it took very long to charge a car with a mobile charging system. The Wallbox is, I would say, still a little bit faster, but still needs a lot of time. The public charging station, depending on the level of the power level, leads to much shorter charging times. This is for sure something we also see in installation costs. A mobile charging system is very flexible, mobile, less components, also less complexity. Therefore, I would say that the installation costs are quite less. If we compare this to a typical Wallbox, a Wallbox is, I would say, still also with less installation costs, but for sure they are even higher compared to a mobile charging system. We need several components, and therefore it's higher. The highest installation cost is what we normally see with the public charging stations. I mean, the reason is quite simple. We need much more devices inside. We need the device like, for example, also a smart meter or something like that to see really what it's, how much it costs to charge a device, your car, and therefore, the installation cost and the complexity is much higher. So with that, I would like to hand over to the next question. The question is really, what kind of components and requirements do we have for these kind of charging systems? Here, I would like to start explaining this with the central part here, the Wallbox. If we look on a typical Wallbox, we see normally several components of this Wallbox. One component here is, for example, the display, but also the cover is some very important component here, especially if we talk about optics. If we talk about other requirements like flexibility, and also we have also a charging cable, and for sure the loading gun, which belongs to the Wallbox. And for sure, not to forget, also the housing. If we look in a Wallbox, we also see different important parts like breaker switches and all the individual safety components. But also parts like the mounting bracket, which is not visible from the outside, plays an important role in the Wallbox setup. And with that, I would like now show you a few more components in detail and talk about the requirements in detail. If we take, for example, here a Wallbox cover, this is what you see here highlighted. We have one innovative material solution to offer. This is called Ultramide Deep Gloss. With the Ultramide Deep Gloss, we are able to realize high gloss inserts without any additional painting. That means you see here on the right side, this is a demonstrator part out of our Technicum. So we realized that in several colors. This part really comes without any additional painting. If we look now also on other properties like surface textures, scratch resistance, and also chemical resistance, this is one material we could offer to solve all these issues. Especially if I talk about surface textures, we see here in this demonstrator part that we are able to realize different surface structures. For example, you see here also the BASF claim, but we have also here these bubbles highlighted. So we could really realize different surfaces in one part with one material. And as I said, also important for these kind of applications, excellent scratch resistance and good chemical and UV resistance. If we now go to another part, for example, here the display, I mean, we have also several material solutions to offer. The material I would like to show today is the Ultramide Vision. With the Ultramide Vision, we have a semi-transparent PA6 grade, which has also a high scratch resistance and a good chemical and stress cracking resistance. You see it here on the right side that with that material, it's semi-transparent. We are also able to offer it in different light colors. So you could really fit the material to your Wallbox design you have. As I said, we have also chemical resistance and good stress cracking resistance, which is an important property of these kind of applications. And especially for that material, We have also the UL94 V0 listing in terms of the UL94 test, but in combination with the hot wire ignition test and the hot arc ignition test, we are also able to achieve here a V0 rating according to UL746C. And this is something also a very important property of this kind of material if you require a UL746C V0 rating. So these were, let me say, more design-driven components of the Wallbox. And with that, I would like now to hand over to my colleague Andreas, who is giving you more overview about also structural components of the Wallbox.
So thank you, Patrick, for your introduction. So Patrick gave us more hint what is regarding design, what we can do to make our Wallbox unique. I want to give more an overview how we can install the Wallbox, what is in the inside, and how we can connect it to the car. And at the end, what happens in the car? Are there any parts we have to take care about when we talk about charging? So let's start with the housing. When we talk about the housing, it very often is the case that a standard material is fine. So you can use, for example, a PPT, which is not flame retardant. Very important are the mechanical properties, but also the processability is important. If you have further requirements regarding flammability, you can also use polyamide 6 types with the flame retardancy. Again, here we have the UL746C. We have non-flame retardant additives. And we also have here the yellow card. We see again there is a good PLC listing, especially when we talk about the high amp ignition, and the V2 listing we have at 0.7 millimeters. When we talk about how connect the Wallbox to the wall at the end, we have the so-called mounting bracket. For such a part, it could be very important to have a low warpage behavior. This makes it much easier during the assembly process. Then we also have another requirement when we talk about Wallboxes. It's the glow wire flammability index. This should be above 650 degrees Celsius. But why is it important? The background here is that if you load your electrical vehicle, you need several hours. And of course, you do not sit next to it. And maybe it's in your garage, in your house, and you will not sit next to it. And so the Wallbox becomes an unattended household appliance. And for unattended household appliance, the glow wire performance is always very important. If you have some more challenging requirements regarding flammability, we can also talk about a V0 grade. In this case, it's in polyamide 6 with 30% glass fibers, the so-called B3U50G6. This product was especially developed for unattended household appliance and fulfills the standards for IEC 60335. So that means it really has excellent glow wire performance. What we can also see on the yellow card is that this product has a good aging behavior. When we talk about the electrical properties, especially here, we have RTI values up to 150 degrees. And again, this product is also based on non-halogenated flame retardant additives. Coming now to the loading gun. The loading gun is the part you need to connect the Wallbox with your car. In general, a loading gun is made out of different parts. Here I want to start with the housing material. The housing material could be made out of a polyamide 6, which is unreinforced. For me, it's important to be unreinforced because the toughness is very important. We have one very challenging test when we talk about the loading gun, that's the overdrive test. So you have to drive over the connector with the car, and then at the end, it should be not damaged too heavily, so there should be no free electrical contacts. Therefore, you need really a high toughness. With that product, with the B3S, we can offer a V2 listing on the yellow card, although we do not add any flame retardant additives to it. So that is also helpful for the toughness. And in addition to that, we have the F1 listing on the yellow card. F1 listing means we already did some UV tests, and this shows to you that this product also have a good UV resistance. A chemical resistance, of course, we have in addition to that, as it is a polyamide 6. When we talk about the contact carrier, so this is the part where the power goes through, you have the electrical contacts in these holes we can see here. Very often you need a V0 product for this part of a loading gun. Here we can offer a polyamide 6 with 30% glass fibers again, V0 listing at 0.4 millimeters, and a high CTI of 600 is also important here. Patrick already mentioned different design products where you can make your Wallbox unique. We have something similar when we talk about a loading gun. We very often hear that we have some haptic elements, which is here in blue on a loading gun, and herefore you can use some TPUs. TPUs are our Elastollan grades, and especially for the loading gun, we can offer the 1185 series. We have again a good UV resistance, and in general, the Elastollan types have a good adhesion to polyamide, which at the end, of course, it's important to have a good and safe product. Coming now to the inner part of a Wallbox, here we talk about different safety components, switches. It's a bit similar to a switch box you have at home. So you also have breakers and switches at home. And at the end, you can also use similar products for these applications. I do not want to go in detail on every product here. What we have is Ultramide B, that's our polyamide 6. We have different flame retardant additives. We have Ultramide 8, it's the polyamide 6.6. And what is new here in this presentation is the Ultramide C, C3U in this case. This is a polyamide 6.6.6. This product is unreinforced, so has a high toughness and a V0 rating at 0.4 millimeters. All these products fulfill the requirements according to UL, IEC, CCC, and so on. So there's really a big product portfolio where you can play with. And here we invite you to contact us so that we can discuss your project when we talk about safety components, breakers, and so on, so that we can offer the right product for your requirements. So closing the topic of Wallbox, I'm coming to the public charging station. This will also become more and more important in the future, especially when we talk about fast charging. So that is direct current DC fast charging. How does a public charging station look like? We have some further components in, for example, the smart meter. This is important for you, that you know what you have to pay after the loading progress. We also have some tubes in it, especially when we talk about DC charging. Some heat will generate it due to the high power, and you have to cool down the systems. And for the coolants, you need some tubes. Here we also have different products for the extrusion process in our portfolio. We have the loading gun again. The loading gun looks a bit different to the loading gun of a Wallbox. We have again the contact carrier for the AC part, but in addition, we also have the contact carrier for the DC part. So that is different. And what we also need, and that is what I want to focus on the next two slides, is the power electronics, the so-called IGBTs, the converters we need for DC charging. When we talk about the power electronics, of course, we need a good electrical insulation when we talk about AC or DC. Also, a high RTI value is of advantage because we will generate some heat due to the high power. Constant dielectric strength also is very good to have. We can also offer some products regarding thermal conductivity. Sometimes there is a risk of hotspots, and then it could be a benefit if you use a product with a thermal conductivity which is higher compared to standard materials. We can offer a product where the thermal conductivity is 3 times higher compared to a standard product. And one very new challenge and very challenging requirement is that we recommend to use products with a very few free ions in. The reason is if you have DC currents, the power goes always in one direction. And if you have now too much of these ions, which are free in the polymer, they can start to move from one direction to the other, and at the end, it can lead to an electrical corrosion. And if you have electrical corrosion, you will have an unreliable system at the end. So this is something you should avoid. Therefore, we developed a product which I want to show you on the next slide. This is the so-called Ultradure B4450G5. It's a flame retardant product. It's available in black and in uncolored. And we did different tests. We did 2 tests for it. And I want to show what we did. First one was the corrosion test. What we see is the material out of the electrical contact. In this case, it's copper or brass. We took it in a glass, add some pellets to it, add some moisture to it, so some water. We closed the glass and then we stored it in a chamber at 70 degrees Celsius for 55 days. After 55 days, we took it out and had a look on the contacts. And what we see, if we use the pellets out of a standard flame retardant PBT, that there was really a heavy corrosion on the metal contacts. This, as you can imagine, will lead to unreliable systems. But the picture looks completely different if you use the B4450G5. So there's nearly nothing happened on the electrical contact. So this is how it looks like after the storage when you use the right product. The second test we did was regarding deposits. It's also quite a big challenge when you talk especially with flame retardant additives. If you have flame retardant additives in your product, there is the chance that some of them came out. Then they go down to the metal contacts, you have a deposit on it. With this deposit, the electrical resistance will go up, so the power will increase, the temperature will increase, and you have, again, more deposit, and so on and so on. And to avoid this, we also did a very simple test. We stored the contacts out of metal together with the pellets out of our product at 150 degrees Celsius for 7 days. And then we had a look on it, and we saw that with the standard flame retardant PBT, we have a deposit on the contact, and we do not see it when we use the B4450G5. So for both tests, you can really have an advantage using this product, and you will have a significant reduced risk of corrosion and deposit. So that was how we have the charging infrastructure, but now we want to go to the car, and are there also some parts at the car we have to take care about when we talk about charging. So when we have the cable connected to the car, then as a next step, we have the charging inlet. So let's say that's the entrance in the car, and behind the charging inlet, we have these orange high voltage connectors together with the orange cables to distribute the power in the car. Starting with the charging inlet, we have some similar requirements as we already had at the charging gun. We again have high mechanical strength. We have again the UV resistance. Again, it takes several hours, and during a sunny day, it's better to have a product with a good UV resistance. And of course, also a high CTI is of advantage. This part, also similar compared to a charging gun, is made out of different parts. So you can use different products. We can use a polyamide 6 with 30% glass fibers, B3G6, for example. We can also use B3U30G6. This is a flame retardant product with a UV2 classification, a good UV resistance. And again, especially when we talk about DC and the charging inlets, the B4450G5 could be a good choice here. Coming now in the car to the charging, to the high voltage connectors to distribute the power in a car. Here there is a new challenge coming with us. We can use different products. So at the end, you can use Ultradure, that's PBT. You can use Ultramide, which is polyamide. This is up to you. It's up to the design and define the requirements, also from the OEM. We know that there are HB materials in the market, and we have V0 materials. CTI is important. The hydrolysis resistance is important, especially when you talk about PBT grades for such an application. But what is new and quite challenging also for us as a material supplier is the color orange. It is not only that you have to make it in orange, you also have to stabilize the product that it is still orange after a heat aging process. So we developed several grades, some PBT grades some years ago. We have two different types. Both are hydrolysis resistance. This is what these HR means. And this one is the non-flame retardant product. And you see at 130 degrees for 1000 hours, there is just a very slight change in color. So there's still a nice orange, which is important due to safety reasons that you see there is high voltage behind. So as a signal color, it's important to have this orange also after heat aging. You can also use an HR modified PBT, the B4450G5HR. It's also available in orange in this case. And also here we can see that after 1000 hours at 130 degrees Celsius, we have still a nice orange. Having said this, having developed this product, we also know that in the market, we need an Ultramide, so a polyamide for this application. It is much more challenging compared to the PBT to achieve the color stability. Because normally if you have a polyamide 6,6 here, in general a polyamide 6,6 after heat aging turns into a brownish. That is very typical for polyamide 6,6. Here we can see it at 90 degrees. It is still okay. 130 you have a brown and you have a really dark brown when we talk about heat aging for 1000 hours at 150 degrees. So this was for the uncolored product, which is not stabilized. We have, of course, more or less the same picture when we talk about the orange product, which is not stabilized. So it's not enough to just change the pigment so that you have an orange grade. You will lose the orange color if you do not use the right base polymer. And this is what we did in our latest development. What we can see here, these are the latest developments. The first one is the non-flame retardant one. We developed it into different glass fiber reinforced grades. And we also have here the A3U44G6DC. DC stands for durable color. This is the flame retardant one. We have the V0 listing at 0.4 millimeters. The yellow card with the generic RGI values are already available. And we also have samples for molding trials available. What we see when we have a look on the aging, on the color, we are at least at the same level than the PBT grade. So this is really a great achievement we did. And so you can now use PBT or polyamide, and both products shows a good color stability. To summarize the, let's say 30 minutes, we have the electrification in the automotive industry, and this will influence the whole market when we talk about cars and so on. When we talk about e-cars, it's also important to talk about the charging infrastructure, because we can do this transformation only if we also have a good charging infrastructure. We as BASF, we can offer products where you can combine design aspects together with a really good chemical resistance. We can offer a broad portfolio of flame retardant products. For all of our flame retardant products, we have a yellow card available. And in addition to that, we have also different yellow cards available for non-flame retardant products. When we talk about fast charging, so about the DC charging, we have to take care about the electrical corrosion. So these are some new challenges. And when we want to distribute the power in the car, we need this orange color. And also for these orange colors, we have different grades available. So with that, I want to say thank you for your attention. Thank you all. Take care.
Thank you. Bye.